Git, a distributed source control repository. I try to picture clusters of information as they move through the file system. Were the commit messages like history books? I kept dreaming of a repository I thought I'd never see. And then, one day, get real.
You're watching Get Real, and this is level 4, where we're going to be going over some collaboration scenarios. What happens when things don't go as smoothly as Olivier showed you in the previous level. So here we have Greg. He pushes up his source code to GitHub, and Jane, of course, wants a copy. As we saw, Jane is going to clone his copy off of GitHub, and then she's going to want to add some changes. So let's continue down that timeline. So she adds some changes. You can see there's 2 new files. We do a git add -- all to add those files, and then add store and product models. Then she pushes up to GitHub when she's done making her changes. And her commit is going to be represented by that little pink commit down there. Now let's jump back over to Greg. See, Greg is also working at the same time as Jane, and Greg makes a commit, basically adds a change to the README. So now we have Jane's commit, which is sitting up on GitHub, and Greg's local commit, which is sitting on his local repository, and they are different. So what do we do at this point? If Greg tries to push to GitHub at this point, well, he's going to be rejected because, as you can see here, the tip of his current branch is behind the remote branch. So what we'd have to do here is we could simply do a pull first and then a push, and it would work. It's important that we know what's going on under the hood when we run this pull command. So the first thing that pull does is it fetches or syncs our local repository from the remote one. It's the same thing as doing a git fetch command. So in this case, it's going to copy down Jane's commit into our local repo. However, it's not actually going to update any of our local code. If we looked under the covers here, we would see that in our local repo, we actually have a branch called origin master. That's our remote branch. And now the second step with pull is that it merges the origin master with master. It's the same thing as running git merge origin master. So just like you saw with the previous level, when we try to do a merge for 2 different branches that have different commits, it's going to pop us straight into an editor where we have to create a merge commit. In this case, our message says that it's merging branch master from a remote repository. Once we save from that editor, it's going to give us some output from the pull command and tell us that it did a recursive merge. If we look back at the timeline, we're going to see that we had 2 branches and they merged on the merge commit. You might notice here though that we have our local master still has that merge commit, but the origin master doesn't yet know about Greg's change and about the merge commit, and it's not going to know about it until we do git push. At that point, origin master points to the same master branch, and everything's been updated. And now if we check the log, we can see there's our merge commit. Now, some people aren't big fans of merge commits. Some people think they pollute our repository, pollute our history, because if you have a lot of collaborators, you might have 10 things that changed and maybe 3 or 4 of them are the merge commits. It can start to get pretty sloppy. And in a later level, we're going to be talking about rebase, which is one way to get around doing these merge commits. But for now, let's move on to another scenario. So Greg and Jane, once again, are working on the same code at the same time. Except this time, they happen to be working on the same file, the same README. Greg thinks the cake is a lie, and Jane thinks the cake is telling the truth. And they both edited that same file. Jane committed her changes and pushed to GitHub, and Greg just committed locally. So now you can see that we still have 2 different commits, but they're on the same file. What's going to happen now? So when Greg does a pull, it does 2 things. Remember, it syncs the repository, pulls down the changes, pulls down Jane's commit, and then it tries to merge. But the merge was not successful. We have a conflict. It tells us there's a conflict in README. So we're going to have to edit that README since it spit us back out in the command line. If we do a status, we can see that, well, we have to edit this file and then make a merge commit. So if we jump into the README at this point, we're going to see what kind of looks like a diff. Inside this diff, it has our local version, that's the head, and we have Jane's version. We're going to need to edit this file manually to fix it. So we're going to delete all the extra text and make it so that the cake is a lie, because that's what we think, well, it is a lie. And then we just call git commit -a. We're going to leave off the message because it's going to boot us back into an editor. It'll give us a good commit message and even list the conflicted files that we fixed. Once we save that, our tree again looks something like this with our merge commit. And once we push, once again, the origin master syncs up with our local master. So we reached the end of level 4, and now you know a little bit more about merge commits and conflicts, and it's time for you to resolve some of your own conflicts in the challenges.